Objective for today, I can identify the greatest common factor, least common multiple of monomials. Read together, 1, 2, 3. I can identify the greatest common factor and least common multiple of monomials. So, we already finished equations, linear inequalities, systems of equations, systems of linear inequalities. And we're moving on to other systems, but before we move on, I need to take a back step and revisit expressions again. That's why if we notice, we're on what? Monomials again. And monomials are not equations. They are what? Expressions. Everybody understand so far? However, we need to really revisit two skills, which is the greatest common factor and least common multiple. You did that when you were in elementary. You guys remember that? Yeah? Very good. However, before I get into the lesson, I'm going to use a tool that you guys use in language arts to compare stuff. Who's used Venn diagrams? Yeah, right? But now I'm going to use it in mathematics. And by the way, we use other language arts tools here in math. Do you guys know that? Like the Cornell Notes. The Venn diagram is also a language arts tool, but they all work well here in class. So let me show you first how to use the Venn diagram. Ready? Here we go. So I'm going to use the Venn diagram right now. Whoops, sorry. The Venn diagram to compare two people. It says, what do I have in common with Michael Jordan? All right. So here's a circle for Michael Jordan. And let me zoom out. Hold on. And a circle for me. I got this. Hold on. So let's see. First thing. Michael Jordan is tall. Well, guess what? I'm not that tall. Michael Jordan is a basketball player. Well, guess what? I'm a teacher. So do we have anything in common yet? No. Next. Michael Jordan is rich. I'm not.
No, that's not true.
Michael Jordan is not rich? Yes, he is.
No, you're rich.
No, I'm not.
You're rich of equations.
Thank you. Yeah, but we're talking about monetary value here. So Michael Jordan is rich. I'm not. But one thing that that caught my attention when I was younger, that made me follow his career, was this: that his favorite subject was mathematics. They did an interview and they were asking him what was his favorite class in school. My math class, my math teacher. He kept talking about math. And I was like, let's go from the corner. So therefore, that made me follow. Aside from how awesome he was on the court, but because he loved math. So question: what is the one thing, or let me say it like this: what is the greatest thing we have in common? We both love math, or our favorite subject is what? Math. Now, question: did I write favorite subject math 2 times here? One for each circle, one for the green circle, one for the red circle? No, we only write it once because that's what is in common for both. So therefore, this part in our Venn diagram right now, when we get to work in a little bit, would be the greatest common thing that both circles will have in common. Everybody understand? All right. So this is how we're going to use the tool for today, which is the Venn diagram. Okay. However, let me clarify one more thing really quick. We're going to talk about a term which is factors. The term factors means 2 or more numbers that multiply. Look up to the screen. So factors are 2 or more numbers that multiply. 2 times 3. Are those factors? Yes, because they're multiplying and it's 2 or more. How about 2 times 3 times 5? Are those factors? Yes, because 2 or more that multiply. What if I wrote 2 plus 3?
No.
Those are not factors because they're not multiplying. It's obvious, right? All right. So I'm going to be talking about factors. The other 2 terms that I'm going to be talking about are prime numbers and composite numbers. Prime numbers are numbers that only have factors of 1 and themselves to create that number. For example, I'm going to start with the number 2. Number 2 is a prime number. Why? Because number 2 can be created by multiplying 1 times 2. We're not looking at fractions right now, just whole numbers. Hold on to your thought. Here it goes. So therefore, 1 times 2. Do you agree with that? Yes, this is a prime number. Okay. How about 3? Is 3 a prime number?
Yeah.
Let's find out. 1 times 3. Are there any other two numbers that multiply to give me 3? Without getting into fractions or decimals. No. So that's it. How about 4?
No.
That one is a composite because it's 1 times 4 or 2 times 2. How about 5? Prime, 1 times 5. How about 6? Composite, that's 1 times 6 or 2 times 3. How about 7? Prime, that's 1 times 7. How about 8? Composite, 1 times 8, 2 times 4. How about 9? Composite, 1 times 9 or 3 times 3. How about 10? Composite, that's 1 times 10 or 2 times 5. How about 11? Prime. And I'll stop right there. You guys get the picture. Question, yes?
Can you put 23 as a prime number?
Bam, let's go. That is true. 23 is a prime number. All right, but I'm not going to do that right now. And of course, yeah, 23 because 23 is always number 1 times 20. Fucking my, all right? Okay. So, any questions on prime numbers? Okay, so we're going to be using the first 5 prime. What are my first 5 prime? 2, 3, 5, 7, and 11. What are my first 5 prime? 2, 3, 5, 7, and 11.
7, 11.
Yes. Okay? So, with that said, we're going to go straight into problem number 1. So like that, I can show you the process that I want to see today. We're going to create find factorization, and then we're going to use the Venn diagram to find our Gcf and our LCM. Okay? All right, so let me go to example number 1. Copy this. All right, example number 1 says, what is the greatest common factor and least common multiple of 24 and 36? Copy that, please. Copy it, and I'll go over the process. All right, writing utensils down. Writing utensils down. All right, eyes up on the screen. So here goes the process. In order for me to find the Gcf and LCM, I'm going to have to follow this process, and I want you to do the same. Now, I know in elementary they have you build factor trees, and they have you do branches. Remember the branches and all that?
Yeah.
Okay. Some of you did it a different way today. I'm going to show you using factor trees, but I want them used in a specific way, in this way. Step 1, I get the 2 numbers, and I write them side by side. 24, leave a space, and 36. Second step, I'm going to write my first 5 primes somewhere on top. 2, 3, 5, 7, 11. Now I can begin finding my factor tree for this one. So, I start with 2 factors. Question, which number, and I'm talking about prime numbers, which one of these 5 primes divides evenly into 24? 2 or 3. So I'm going to go with the highest one. So I always start with the highest prime number, 3. So 3 times what gives us 24? 8. So I circle 3, and that branch doesn't grow anymore because it's a prime number. Look at 8. It's a what? Composite. So that means I can still do what? 2 more factors. Which one of these again divides evenly into 8? 2 times 4. So I circle this one. It's a prime. How about this one? 2 times 2. Well, guess what? As I write these, I'm done, and I don't have any more numbers left. All these are called prime numbers. Do you agree with that? However, once we write them like this, I bring this down, 3, 2, 2, and 2, and I do this. Tell your neighbor, what would I call these now? These will be called prime factors. Why factors? Because now they're doing what? Multiplying. Okay. Any questions up to right there? Now, this is prime factorization because all these numbers, if I multiply them together, should give me the original number. What is 3 times 2? Times 2 times 2. That is correct. That's how you find your prime factorization. Therefore, I want you to copy this, and then I want you to find me the prime factorization of 36 using the same process. Copy and go. All right, let's see. You start with 2 factors. Which one of these for 5 prime divides the ability into 36? 2 and, so I'm going to go with 3, the highest one. So 3 times what gives 36?
12.
12. Circle the 3, and that stops scoring there. This is a composite, so I open 2 more branches. How about this one? 3 times 4. Circle the 3, go to 4. This becomes 2 times 2, and I don't have any more composite left over. So all these are my prime numbers. However, I write them like this: 3 times 3 times 2 times 2. And what are they called now? Prime factors. Hands if you got that by yourself. Okay, good? So let me go over the process one more time. We wrote the 2 numbers side by side, leaving some space. Second thing, I wrote my first 5 primes. From there, I find prime factors for the first number, prime factors for the second. Are we there? All right, writing utensils down. Here goes the next part. Please stay focused. Ready? Here it goes. I'm going to create a Venn diagram. So, 1 potato, 2 potatoes. So, this potato right here is for the number 24, and this one for number 36. Are we there so far? All right, so now check this out. Question. Remember that I used the Venn diagram for Michael Jordan and myself? Yes? And I said, what is the greatest thing we have in common? And it went here, right? So question, what factors do both of them have in common? Okay, first, do we have a 3 for each side? Yes, 1, 3. Do we have a 2? Yes, right here. Do we have another 2? Yes. All right, so for both, what would I write in here? 3 times 2 times 2. Do I need to write it twice? No, because that's what they have in common. Well, guess what? This is our greatest common factor. What is 3 times 2? Times 2, 12. Hold on, don't copy that yet. Any questions up to right there? All right, but this problem states that we need to find the what now? The least common multiple. So watch. What's left over here that we didn't use? So I'm going to write it here in this space, times 2. What's left over on this side that we didn't use? 3. So I'm going to write it here. All right, so check this out. To find my least common multiple, all I have to do is multiply all these that way, LCM. Let's see. This is 12. We know that, right? So what is 2 times 3?
6.
What is 6 times 12? 72. That is correct. That's my LCM. Now, is that the only way of finding the LCM? No. Check this out. Look up. Ready? Because I'm about to, like, boom. What's left over on this side? 2. If I multiply times the opposite number. 72. How about what's left over on this side? Multiply times the opposite number. Copy that, please. That's how you find your GCF and LCM using the Venn diagram. I know, right? Let's go from the corner. Copy that. All right, let me recap the steps. Here we go. They wanted us to find the greatest common factor, each common multiple of 24 and 36. What do we do first? Write them side by side. Leave a space in between. Next step. What do I do next? write my first 5 primes just to have them there so I can focus on where I start. Next, create a factor tree for each, and I always start with the greatest prime factor of these 5 so that the branch stops at each step. From there, we write the prime factors. What do we do next? Venn diagram, find the what? Gcf. Then we write whatever's left over on each, and then we find our LCM. Okay? Let's see. So far with one example. Show me with the fingers how comfortable you are. 1 to 5. Got some 5s, 4s, 5s, 4s, 5 4s, 3s, 4s, 5s, 4s. Okay. Let's do another one. Do this next one by yourself. And by the way, at this point, I always have some students saying, Mr. Cuba, why don't we always write it only once in the center? Because that's what they both have in common. Another way of looking at it is like this. Let me show you with animation. I did some animation for this problem. Here's the factors for 24. Here are the factors for 36. Everybody there? So watch. When they overlap, how many do you see only in the center? One of each. Do we see both sets? No. That's why we only write it one for each. Are we there? All right. So let me go to example number 2. See if you can do example number 2 by yourself. Copy this. Example number 2. You don't have to copy the instructions anymore, but the numbers are, find the GCF and LCM of 12 and 18. See if you can do that process completely by yourself. I'll give you a head start. Ready, go. Copy that and go. All right, let's see. Here goes the process one more time. We wrote 12 and 18 side by side with a little space in between, yes? You wrote your first 5 prime, 2, 3, 5, 7, 11. And I start with 12 with 2 branches. What is the first prime that divides evenly? The 2, but what is the greatest one? 3. So I write 3 times 4. Circle the 3. From there, 4 becomes what? 2 times 2. So circle both. My prime factors are 3 times 2 times 2. Hands if you got that. Okay, good. From there, I go to 18. Open up 2 branches. Which one of these divides evenly? The 2, but also the what? So I start from 3. 3 times 6. Circle the 3, and this one is 3 times 2. Circle both. So my prime factors are 3 times 3 times 2. And so we got that. All right, now that we're done with prime factorization, we create our Venn. 1 potato, 2 potatoes. This one is for which number? 12, and this one for number 18. So, what do we have in common here and here? Do we have at least 1, 3 for each? Yes, so I write it here. Do we have at least 1, 2 for each?
Yeah.
Yes. Do we have anything else?
No.
No, we're done up to right there. So my GCF is what?
6.
6. All right. What's left over on this side?
2.
Times 2. What's left over on the other side?
Times 3.
Times 3. Therefore, to find my LCM, you can multiply all the way across, or tell your neighbor another way of finding the LCM given that diagram.
You multiply times 3 to the opposite number, or times 2 to the opposite number.
So, some of you did this. You did 2 times 18, which was what? 36. Sounds if you got LCM 36. All right, show me with fingers how comfortable you are with these. Okay, we're good, right? All right, let's crank it up a notch, yeah?
Yeah.
All right, here we go. So, go to example 4. Example 4.
Oh.
All right?
Oh.
It says, example 4, what is the greatest common factor, least common multiple of 60x cubed and 72x to the 5th? Write those down, please. 60x cubed. I'll write it here. 60x cubed and 72x to the 5th. Bless you. All right. So let's follow the same process that we did for the previous one. We wrote our 2 numbers side by side. What is the next thing? Write my first 5 prime. 2, 3, 5, 7, 11. Okay. So let's do with what we know so far. Start with 60. Which one of these first 5 prime divide into 60? Okay, does 2 divide? The 3, but the biggest one is? So it's 5 times 12. So we circle the 5. We go with 12 now. What is the biggest prime factor that divides in evenly? So it's 3 times 4, and then the 4 is 2 times 2. So my prime factors are 5 times 3 times 2 times 2. Are we there so far with a number? Okay, so check this out. Look up, please. How can we write x cubed in prime factor form? Tell your neighbor, please.
You put parentheses around them, and then you put x to the house.
Okay, prime factor form is x times x times x. Copy that. All right, let's go with the next one. Let's go to 72. We open up 2 branches. Which one of these divides evenly? The 2, yes. How about the 3? Yeah, so it's 3 times 24. Circle the 3. The 24 is what? 3 times 8. Circle the 3. About 8. 2 times 4. And the 4. 2 times 2. So my prime factors are 3 times 3 times 2 times 2 times 2. We're done with the number. Tell your neighbor what to write for x to the 5th right here. That is correct. X times x times x times x times x. All right. Is everybody following up to right there? Pretty good? Okay. Let's open a Venn diagram. 1 potato. 2 potatoes. This one is for 60x cubed, and this one for 72x to the 5th. Okay. Let's find our GCF first. Do both of them have a 5 in common? A 3. Yes, at least one, so I'm going to underline this one and that one. How about a 2? Yes, this one and this one. How about another 2? That one and that one. Done with numbers on this side. This one has x. How many x's do they have in common both? 3. So I'm going to underline both sides 3. So tell your neighbor what to write here in the center, please.
3 times 2 times 2 times x times x times x.
Okay, help me out, Esmeralda. What do I write? Hands, have you got that? That is correct. 3 times 2 times 2 times x times x times x. And guess what? This is our what? Our GCF. Let's multiply them all. What is 3 times 2? Times 2? 12. And what is x times x times x? X to the 3rd. So this is my GCF. Are we there so far? All right, let's go and see what's left over on this side. Did we use the 5? No. What else is left over? That's it. So we write it here, times 5. What's left over on the other side? 3. What else?
2 times double x.
Times double x. So this is times 3 times 2 times x times x. All right. Tell your neighbor which way would be the easiest way to find the LCM given that. Okay. Which will be the easiest way? Paul. He said multiplying to the right all of these. Okay. Is that the easiest way?
No.
Which one times what? Oh, 5 times 72x to the 5th. Hands, if you agree with that? That is correct. So what is 5 times 72? 360, and we bring down the x to the 5th, and that's our LCM. That is correct. You guys think we'll get the same number, same expression if I multiply all of these together?
Yeah.
Yes, that will get the same thing. Let's go from the corner. Some of the fingers, how comfortable you are with these? Yeah, we just added the variables, so you just need to write them in prime factorization form. Does that make sense?
Yeah.
All right. It did?
Yeah.
Okay, good. All right, here we go. However, what if I did this? Writing utensils down, look up to the screen. What if I said, find me the Gcf and Lcm of 8, 12, and 15. So what do we need to do? Prime factorization for each, and then how many circles?
3.
3. 1 for 8, 1 for 12, and 1 for 15. 8, 12, and 15. Where's my GCF? Right there. Is everybody following? Okay. What if I did this? 4x squared.
Huh?
10x to the third, and 2x. Once again, how many circles?
3.
1 for 4x squared, 1 for 10x cubed, and 1 for 2x. Find your prime factors. What do they have in common? Goes here. What's left over between these two? So you write here and here. What's left over between these two? You write it here and here, and so on and so forth. Everybody with me? All right, copy the home play for tonight. Home play, yay.
That's complicated.
Nice. You don't have to copy the instructions, but it says identify the greatest common factor, least common multiple for the following problems, numbers 1 through 10 only. I'm sorry, 1 through 9 and number 23 at the end. Yay. Copy those.
What is a pen?
23 is always a 10. Bam. Let's go. So I'm gonna go ahead and turn off the video, but this will be on YouTube in case you think you missed something from the lesson. All right, guys, enjoy your home play. There is tutoring. If I don't see you guys tomorrow. Bye.